Hello everyone, welcome to Engineering Explained channel. In this session, I am going to discuss the details of deadweight loaded hydraulic accumulator and spring loaded hydraulic accumulators. I'll take how those accumulators work and their function, and also we'll take some of the advantages and disadvantages concerned to those accumulators. This is deadweight type hydraulic accumulator. The hydraulic accumulator definition already we have taken, which will stores the pressurized fluid in it when the system pressure is high, and that will supply that pressurized fluid to the system when it is needed by using the any of the load, either it may be dead weight or spring or a gas pressure. And these accumulators we are going to use for the different applications where damping is required, okay, shock observation, and also the pressure regulation, reducing the pulsations, and all these things are there. For those purpose, we are going to use the accumulators. And here, this is the dead weight loaded hydraulic accumulator. It consists of a cylinder where the supply of the fluid is connected from the pump, and it consists of a piston and dead weight and provision to make the load the dead weights. There is a platform, and when the pressure in the system is higher, then fluid enters here, and that will lifts the weight in the upward direction, and that will stores the energy as a potential energy of the weight. Then that will be initially it will be position A, and when it is lifted it will reach to the piston reaches to the position B. When the system pressure is reduces, becomes lower, and during that time, due to that load by the dead weight, the piston will be moved in the downward direction, and the fluid will be come out from the accumulator and supplied in the system, and that will making the different requirements, fulfills the different requirements, and that already I have discussed in the previous session. Okay, what are the requirements of these accumulators? Further, we'll take the working of this deadweight loaded hydraulic accumulator. A deadweight loaded accumulator or weight loaded accumulator is a type of hydraulic accumulator that stores energy by lifting a weight with the hydraulic fluid pressure, storing potential energy and releasing it when needed. How it works? The accumulator consists of a cylinder and a piston rod with a dead weight attached to the piston rod. As hydraulic fluid is pumped into the accumulator, the piston rises, lifting the weight. The stored energy is in the form of potential energy of the raised weight. When the hydraulic pressure is needed, the weight is allowed to fall, releasing the stored energy and fluid into the system. Advantages of this deadweight type hydraulic actuator can maintain a nearly constant pressure in the hydraulic system. Simple design and construction. Disadvantage: bulky and heavy, making it unsuitable for applications where space and weight are critical. Applications suitable for heavy duty applications where large volumes of fluid are needed. Can be used to store energy for applications like shock observation and as a backup power source. This can be used. Further, next we'll take that is spring loaded accumulator. Here, the spring loaded accumulator, the spring compression and the releasing is used for the loading. It consists of a cylinder, piston, and the spring, preloaded spring. The fluid from the pump enters into the this accumulator, and due to the pressure of the fluid, the spring will be compressed, moving the piston in the upward direction, and that will stores the potential energy in it at a higher pressure. When the pressure in the system will be reduces, during that time the fluid will be starts flowing from this accumulator, and the spring will be expands, and that will be forces the fluid to move in the system. That's why it will be supply the potential energy stored during its compression, and thereby the system will maintain the what the fluid flow and the energy required in the system, and that can be represented like this. This is the representation of the accumulator symbol, and what loading we are going to take, that we can mention above it. There is a spring here, we can mention the spring weight. If it is there, that weight we can mention, and gas pressure, that will be mentioned as a gas. And here we can see the animation of the spring loaded accumulator. When the fluid is at a higher pressure, the fluid enters into a system, and thereby the compression of the spring is taking place, and thereby storing a potential energy. When the pressure reduces, the fluid will comes out, releasing the potential energy stored in it, and that will be supply up the continuous energy in the system. The different parts here also we can see that there is a two hydraulic system flow. O-ring are provided in order to avoid the leakage. Piston, spring, and atmospheric air filter is used. There the during compression air should be come out from that. The working we can discuss here. A spring loaded accumulator is a hydraulic accumulator that uses a free-loaded spring to store hydraulic energy, working by compressing spring with increased fluid pressure and discharging fluid when pressure drops. Function: spring loaded accumulators store hydraulic energy by compressing a spring when fluid pressure is higher, and then release the stored energy by expanding the spring when pressure is lower. Components: preloaded spring. The spring stores the energy when compressed. Fluid chamber. The chamber contains the hydraulic fluid. Hydraulic system connection. This allows the accumulator to connect to the hydraulic system. Operation. First one, as fluid pressure at the accumulator inlet increases, fluid enters the accumulator and compresses the spring. A decrease in fluid pressure causes the spring to decompress and discharge stored fluid energy back into the system. Advantages: spring loaded accumulators can be used for energy storage, damping pump pulsations, and absorbing hydraulic shocks. Limitations: spring loaded accumulators are generally suitable for smaller applications, as the size of the spring and overall accumulator dimensions can become excessively large for larger volumes. Although deadweight type of the accumulator and spring loaded accumulator size are more, where the size limitation is not there, there we can use. Otherwise, this cannot be used, that becomes a limitation for this. This about the two types of the accumulators. Those are deadweight loaded hydraulic accumulator and spring loaded hydraulic accumulator. Already in the previous session I have taken the details of accumulator, how those works, and all the applications and advantages about those. And next session I am going to take the gas accumulators. Thanks for watching. If you like, share, subscribe and comment.